All right, let's dive into one of the biggest questions in tech right now. We have these AI models that are just unbelievably powerful. So why is it so darn hard to make them actually work for a business? Today, we're going to break down that missing piece of the puzzle, the critical infrastructure that's going to turn AI from a cool toy into a reliable digital workforce.
And that really is the central paradox, isn't it? I mean, we've got large language models that can write poetry, they can debug code, plan entire marketing campaigns. It's amazing. But the second you try to plug one into a real, live business environment to do a critical task, everything just falls apart. It becomes this total nightmare of unreliability and insecurity.
And here's the thing. These raw models are kind of like a genius brain in a jar. Super brilliant, right? But they have zero memory of what happened a second ago. They have no concept of rules or permissions, and they're incredibly fragile. A stateless model forgets everything you just told it, from one interaction to the next. An insecure one can't be trusted with any sensitive data. And a fragile one? It just gives up if the server has a tiny hiccup. You absolutely cannot run a business on that.
So that really gets to the heart of it. This is AI's massive production problem. It's not about how smart the model is anymore. It's about everything around the model that's broken.
You know, the wild part is, the models themselves are ready to go. We have officially crossed this critical reliability threshold. The best AI models are hitting over 85% accuracy on some really complex business tasks. So the power's there. The intelligence is there. What's missing is the system to actually deploy and manage it properly.
And that brings us to the solution. And it's not another code library or some simple framework. No. What we really need is an operating system for our AI workforce, a whole infrastructure layer that's built to handle all the messy, real-world problems.
And that's what's called an agentic platform. Think of it exactly like the OS on your computer, Windows or Mac OS. Your OS manages memory, it handles security, it keeps all your programs running without crashing into each other. Well, an agentic platform does the exact same thing but for AI agents. It transforms them from that brain in a jar into something that can reliably get a job done.
Okay, this is a really important distinction to make. A framework, something like LangChain, gives you the tools to build an agent. It's like the blueprint for the engine. But a platform is the entire car, it's the whole infrastructure that runs the agent, makes sure it doesn't crash, and has safety features like locks and seatbelts built right in. See the difference? You build with a framework, you deploy safely at scale with a platform.
So what's under the hood of this AI operating system? Well, it's actually built in layers, and each one has a really specific job. Let's break it down.
This is a fantastic way to think about it. At the very bottom, you've got the kernel, the runtime. This is what keeps the agent alive. If a server crashes, the agent just wakes up somewhere else and picks up right where it left off. Super important. Then there's the CPU, the cognitive layer. That's the brain, handling the reasoning and figuring out which AI model is best for a specific task. Next up, you've got the RAM and the hard drive, giving the agent both short-term and long-term memory. The I/O layer is how it connects to the outside world, to tools, to other agents. And wrapping it all up is the firewall, which provides real security and governance. It's a complete, resilient system from the ground up.
Let's just zoom in on one of these for a sec to see how practical this gets. Layer 4, the interface. This is how the agent actually does things. It's what connects it to your company's tools like your database or Slack. It lets it talk securely to other AI agents to delegate tasks. And this is crucial. It knows when to pause and say, hey, can a human check this before it proceeds? And it can actively go out and find the info it needs to get its job done. And this right here is maybe the most important takeaway of this whole thing. Real security isn't about just telling an AI in a prompt, hey, please don't access the finance database. That's just hoping for the best. Real security is architectural. The system itself, the OS, prevents the agent from even having the ability to access it. It's just like how your computer's OS stops one app from snooping on another app's memory. It's built in. Okay, so we've covered the what and the how. But what about the so what? Why does this all matter? Let's get to the fun part and look at the actual business impact of putting a system like this in place. Wow. I mean, just look at this chart. A typical customer support ticket that's handled by a person costs about $14. That same ticket, handled by an AI agent running on one of these platforms, costs 15 cents. That's not a small improvement. That is nearly a 100x cost reduction. This completely flips the economics of knowledge work on its head.
And when you start to scale that up, the numbers just get staggering.
For a single 100-person support team, if you apply that 15-cent agent to even 80% of their tickets, you're looking at an annual savings of over $5.5 million per year for just one team.
And just so we're all on the same page, this isn't some future prediction. These are not theoretical numbers pulled out of thin air. The source material is based on real organizations that are deploying these platforms today and are seeing these kinds of 10x to 100x cost reductions in the real world. This is happening right now.
You see, this is way bigger than just saving money on support tickets. This is about building the actual foundation for a truly autonomous future, where these digital workers are a core part of every single enterprise. And here's a pretty practical roadmap for how a company can get there. Notice what the first step is. It's not the smart part, it's the foundation. You deploy the runtime to keep agents alive and the firewall to keep them safe. You build the safety and the reliability first. Then you add the intelligence and the memory, and only then do you scale its connections across the whole company. It's a smart, deliberate process.
I think this quote just nails it. It perfectly summarizes the whole idea. It's about taking something that is fundamentally unpredictable, a stochastic AI model, which just means it has an element of randomness, and you wrap it in an infrastructure that makes it reliable, stateful, and secure. You're literally turning a model into a digital employee that you can actually count on to do its job.
And that leaves us with the big question, doesn't it? If AI agents are truly the next evolution of the workforce, this new class of digital employees, then the race is on to build their operating system. This isn't just another app we're talking about. This is the next foundational layer of the entire tech stack, and whoever builds it will, in a very real way, be shaping the future of work itself.